Rational expression is basically a big fraction. So in this big fraction, I have a polynomial in the numerator, and then we take that polynomial over another polynomial. It can be very simple, like x plus 5 over x minus 2. It's that simple. Or it can be x squared plus 3x divided by x squared minus 3x minus 4. So when you check out an expression, you have to be aware the x value that makes the denominator 0. So I should say you have to be aware the x values, because sometimes we have more than one x values that makes the denominator equal to 0. So for example, so let's take the x plus 5 divided by x minus 2. So maybe people will think, all right, so x can be anything you want. Is that really true? Negative, positive, 0. What happens when x is 0? You have 0 plus 5 over 0 minus 2. That is fine. 5 over negative 2 is totally defined. But what about this? What happens when x minus 2 equals to 0? Well, we have a number divided by 0 that is undefined, right? What about 0 over 0? So 0 over 0 is undefined, but you have to study 0 over 0 when you are taking your first quarter or first semester of Calculus 1. So in algebra, we were just thinking a non-zero over 0 is undefined. So for example, negative 1 over 0, 5 over 0, 1,000 over 0, they are all undefined. So when x minus 2 equals to 0, we have a trouble. That's why x minus 2 cannot equal to 0. Just like solving an equation, you add 2 on both sides, so x cannot equal to 2. When you check out this rational expression, you have to emphasize that, hey, x cannot equal to 2, because when x equals to 2, we have a trouble, right? So we have a 2 plus 5, that is 7, perfectly fine. Hey, 2 minus 2, you have a 7 over 0, this is undefined, right? So what about I have some other expression? So let's say I have a x plus 3 divided by two factors. How about x minus 6 times x plus 7? How's that? So this one we have to emphasize that x minus 6 times x plus 7 cannot equal to 0. Okay, so that means x minus 6, just like the zero product property, change the equal to a not equal. X plus 7 cannot equal to 0, so x cannot equal to 6, x cannot equal to negative 7, right? So when x, so this is the restriction. What happened when x is equals to 6? So when x is equals to 6, we have a 6 plus 3. Nothing is wrong with that. This will be a 6 minus 6. And then the other one is a 6 plus 7. So this one you have a 9, but this will be a 0 times 13. You have a 0. So that is undefined. What if x is equals to negative 7? Negative 7 plus 3, perfectly fine. So that means the numerator, basically we can just ignore it, because numerator can be 0. So let's say 0 over 5, 0 over negative 2, 0 over negative 16 is equal to 0, right? So the numerator, a 0 divided by non-zero, is equals to 0. 0 divided by 6 million is equals to 0. But on the other hand, 6 million divided by 0 is undefined. Okay, let's continue the math. You have a negative 7 minus 6, no problem with that, but this is a negative 7 plus 7. That will be a 0. So this one we have a negative 4, right? Divided by 0, so that is undefined. So we have a trouble in there. Okay, can we check out something else? How about we check out x divided by x squared plus 4? Hey, can this equals to 0? X squared plus 4. Can that equals to 0? Tell me. You have pick any numbers you like, negative, positive, 0, I don't care. You square that value. You add 4 to it. Can you get to a 0? No. Let's say you square a negative 2. Negative 2 squared is 4. 4 plus 4 is not equal to 0, right? You square a negative, you get a positive. You square a 0, yes, you get a 0, but you have to add 4 to it. So you still don't get a 0. You square a positive, you get a positive. Positive plus 4 is positive. So that means x squared plus 4 will never equal to 0, right? So if you want me to solve x squared plus 4 equals to 0, this one has no solution. You square any value, you add 4 to it, can never equal to 0. So you any value, you square, you plus 4, hey, you never get a 0. So in this expression, we say that x can be any value. So in this rational expression, x can be any value. Negative, positive, 0, be my guess. Okay, let's move on to the next topic. In the next topic, I would like to reduce some rational expression. So let's draw a line to split up the topic. So how about write each rational function in the lowest term? I have a 5x plus 20 divided by 3x plus 12. So that means you have to factor the top and bottom as much as you can until you cannot factor anymore. The top is easy. 5 and a 20, they are multiples of 5. I will just take a 5 out to see what is left. So this is a x. 20 divided by 5 is 4. The bottom, 3 and 12, they are multiples of what? They are multiples of 3. Then I have a x plus 4. So we have all multiplication on top, all multiplication on the bottom. 5 times x plus 4. So that means, therefore, I can go ahead and then cancel this with that. So that means this answer is 5 over 3. Oh, in case you are wondering with the cancellation. So let's say 5 times 2 divided by 7 times 2. So this one is all multiplication. You can just cancel out the 2. So you can just cancel out the 2. That is equals to 5 over 7. Or you can multiply them. You have 10 over 14. You have a 10 over 14. You can reduce the fractions like that. So either way is fine. But as long as the top is all multiplication, the bottom is all multiplication. The top is all multiplication. That means I have a 5 multiply a factor. A factor means a parenthesis. 3 multiply a factor. So that is what do I mean by all multiplications. Okay, let's check out the next problem. The next problem, how about let's do a x squared minus 16 divided by x squared minus 8x plus 16. Okay, this one, the bottom, you can do a factor, right? So the bottom, you can do a diamond method, 16 times 1, negative 8. And then that one, I have a negative 4 times 4 is 16. The sum is negative 8. So this one, the bottom, I have a x minus 4 times x plus 4. And then for the top, you have to recall this a squared minus b squared equals to a plus b, a minus b. This shouldn't be something on your cheat sheet or your note card when you take an exam. This should be in your mind. So x squared minus 16, which is a perfect square. So that is the 4 square. So you have x plus 4 times x minus 4. Okay, what do they have in common? I'm using the highlighter. So they have the x plus 4 times x plus 4. And then the other one, they have x minus 4, x minus 4. So therefore, they are all cancelled. It doesn't mean you have a 0. So you cancel, you have a 1 divided by 1. You can easily put a 1 in there, right? That doesn't affect anything. So we have 1 over 1. That means the very complicated rational function you have at the beginning is equal to 1. All right? So let's practice the a squared minus the b squared one more time. The next problem, I would like to do this. I would like to do a 16x squared minus 9y squared and then divided by 12x minus 9y. So that one, the 12x minus 9y, 12 and 9, they are multiples of 3. I take it out to see what is left. 12 divided by 3 is 4. 9 divided by 3 is 3. And then the top, I am going to make you write this one more time. A squared minus b squared equals to a plus b times a minus b. And then you have a 4x squared minus 3y squared. The problem will give you perfect square. Then you have 4x plus 3 y times 4x minus 3y. Okay, so 4x plus 3y times 4x minus 3y. That's why they designed the problem in this way. Do you see that? That's why they designed the problem in this way. So you can get rid of the 4x minus 3y with that. Do you see it? And then what do you have left? You have the top, you have a 4x plus 3y, and then divided by 3. Okay, this is one of the ways to write it. You can write 4x over 3 plus 3y over 3, and then that is equals to 4x over 3 plus y. That is another way to write it, but I am good with this. Oh, when you are doing homework online, you can try. Maybe sometimes the system, they don't accept the first one. You never know. Okay, the next problem, this is my favorite problem. I always want to talk about this. Is something that will show up once a while. If you don't know this technique, it will just make you scratch your head for 15 minutes and you have no idea what's wrong in there. Okay, so let's say I have a 2 minus x divided by x minus 2. Are they exactly the same? The answer is no. Let's say 5 minus 2 and then 2 minus 5. Are they the same? No. This 5 minus 2 is 3. 2 minus 5 is negative 3. Hey, there is a negative in there, right? Do you see that? They are not exactly the same. If they are exactly the same, 3 over 3 is just a 1. So I'm telling you that the top and the bottom, they are not exactly the same. So how do we make them look the same? Well, the top, you swap the order. You let the minus goes first, and then a 2. Hey, here, this 2, allow me to change that to a plus 2 because this is a plus. Remember, you have a sign followed by a number. Negative 2, you have a negative followed by a number. Positive 6, you have a plus followed by a 6. And then you take that divided by x minus 2. Well, now they look very different. I have a plus 2 on top, a minus 2 on the bottom. But once you factor out a negative, this is a x minus 2. Agree? You can always put it back. And then divided by x minus 2. Okay, so we are close. X minus 2, x minus 2. So that is equals to negative 1. The answer is equals to negative 1, just like this. They look the same, but after you swap the order, so this one you can do a negative 2 plus 5, and then 2 minus 5, you can see that they are not the same at all. Am I right? Okay, moving on to another problem. Okay, I will just do one more problem and then we finish this video. So the next one, let's do a x squared minus 100. I want to practice your a squared minus b squared again. How about 10 minus x? So 10 minus x, you know what? Let's deal with that later. So a squared minus b squared equals to a plus b times a minus b. So you have x squared minus 10 squared. That is x plus 10 times x minus 10. Okay, so this is a x plus 10 and then x minus 10. How about your 10 minus x? Well, if you take a 10 minus x in there, they are definitely not the same. Okay, I swap the order. Let the negative walk first, and then the plus walk second, and then plus 10. All right, I didn't change anything. And then I factor out a negative 1. I have a x minus 10. You put the negative 1 back, you get back to the previous line, right? So that one we have, let me erase this. So we have a negative 1 times x minus 10. Now they are the same after you factor out a negative. Okay, so I can get rid of this, get rid of that, and then what do we have? We have x plus 10 divided by negative 1. Divided by negative 1 is the same thing as multiply negative 1, right? 10 divided by negative 1, negative 10. 10 times negative 1 is negative 10, right? It is the same thing to write it like that. This is perfectly fine, or some people just keep it like this. I agree with that. This is absolutely fine. Or you can do this. X plus 10 divided by negative 1. x divided by -1, the plus goes right there. 10 divided by -1, you have a negative x minus 10. That is also good. Once you distribute that, you have a negative x. Am I making a mistake right there? Okay, let me step back. So we have a x plus 10, a -1, negative x minus 10. All right. Negative x minus 10. Oh, this one, once you distribute the minus, you have a negative x minus 10, right? And then this one, what am I trying to say? This one, once you divide it, you have a negative x minus 10. Okay, so negative x minus 10, negative x minus 10. So either way is fine. I am good with keeping the negative one outside. Okay, so that is the end of this video. If you like the way I introduce rational expression, teaching you how to do factors, how to swap the numbers and factor out the negative one, give this video a thumbs up, subscribe to my channel for more contents like that. I will meet you all in the next video. Signing out.